Hi everyone, this is the lecture 12 of our series of data science, and our topic of today is association rule mining. So, uh, have you ever wondered how online stores suggest customer who brought this also brought that, and how streaming services recommend music or videos? So that's association rule mining. So, in this video, firstly, we'll break down what association rule mining is. Secondly, real world application like market basket analysis and recommendation system. Third, popular algorithms like a priori and FP growth, matrices for evaluating association rules. So, let's get started. Firstly, what is association rule mining? So, association rule mining is a data mining technique that identifies relationships or patterns in large data set. It's all about uncovering hidden rules between the variables that can be used to make predictions or decisions. For example, in a grocery store data set, the association rule mining might reveal that if a customer buys bread or if they are likely to buy milk. Now, this simple rule can help us to organize products on the shelf, design promotion, or make personalized recommendation. Moving on, use cases of association rule mining. So it can be used. Let's. It can be used where we can use market basket analysis. That is retailers analyze purchase patterns to the understand which items are frequently bought. For example, laptops are bought the most rather than other devices. Next on, we have customer segmentation. That is, it segments customers based on the purchasing habits. This helps companies tailor in marketing campaigns or recommend personalized products. Third, fraud detection. That is, credit card companies use association rule mining to spot unusual transaction patterns like multiple purchases at the same merchant in the short period of time that could indicate fraud. Also, we have recommendation systems like Netflix or Spotify that suggest content based on our past viewing experience or listening history. Now, next on, we have social network analysis. That is, social media platforms that analyze user behavior to identify groups or communities. For instance, Twitter might find users who tweet about fitness often tweet about nutrition. And also, the recommendation system, that is association rule mining, can also suggest items that a customer might be interested based on their past experiences. Now, association rule mining algorithm. So it relies on algorithms to identify patterns and data sets. So here are three popular ones. First is a priori algorithm. It is one of the most widely used algorithm, and it works by identifying frequent item sets, that is combination of items that appear together often, and then generating association rules for it. Next on, we have FP growth algorithm that instead of generating all items upfront, it builds a tree structure and call it as FP tree, which compresses the data set and speeds up the process. Next on, we have eclat algorithm, that is a variation of appropriate that uses top-down approach instead of a bottom one, and it's a faster for certain data sets. Moving on, the Propri algorithm. So it is a particularly popular and easy to understand. Here is how it works. So setting up a minimum, one second, yeah. Setting up a minimum support threshold, that is the minimum number of times an item set must appear to be considered frequently, identifying all the frequent item set in the data set, and then generating the rule based frequent items. Now, consider an example that there is minimum support of 20% and 20% of the transaction contains both bread and milk, and this is the combination of frequent consider. And from this rule, if bread then milk is generated with a confidence score. uh, Now about the appropriate algorithm detection. So it starts by setting a minimum support threshold. Then this minimum number of times an item must occur in the database for it to be considered frequently item. The algorithm then filters out any candidate item set that do not meet the minimum support threshold, and this algorithm then generates a list of all possible combinations of frequent item set that counts the number of items at each combination that appears in a data set. An algorithm then generates a list of association rule based on frequent item set combination. Matrices for evaluating association rule. So not all association rule are equally useful. To evaluate it, we use three matrices, that is firstly support, confidence, and lift. Support measures how frequently an item set appears in data set, that is formalized number of transaction containing the items by total number of transaction, and higher support indicates more common item set. Next on confidence, that measures how often a rule is true, and its formula is transaction with both a b by transaction with a. Example, if 80% of people who buy bread also buy milk, then the confidence is if bread, then milk is 80%. And lastly, we have thrift, that measures the strength of an association by comparing it to a random chance. That is, its formula is lift is equals to confidence of rule by the expected confidence. The lift, if a lift is greater than one, it indicates a strong positive association. Uh, now we would like to go on the coding. So here, this is our association rule in Python. So this notebook covers how mine association rules using Python are implemented, how to apply confidence different criterion, and how to apply confidence question criterion. So let's get started. Yeah, so here we'll start using mextend library to mine associated rule. So let us begin by importing the necessary libraries that are make second. Let's try to run this. One second, I think I have some issue here. So here our code is running now. I have already installed MLX tent library, and then I have import pandas and the same library which has a priori and association rule, and also sample data with milk, bread, butter, jam, and the number of transactions it had, and then getting the first data frame values and analyzing it. These are the distributions and time series and 2D distributions, values. Now next on we have generate frequent item sets using a priori algorithm. So uh, in this step, we'll use a priori algorithm to identify frequent item sets. These are the groups of items that appear together in transaction with a frequency above the specified threshold. Now let's try to run this. So here the min support. Uh, so this is our frequent item set, and the result indicates the item set and their support values. Now the minimum sub here, yeah, I forgot a point. That is the minimum support, that is 0.5. It ensures that only item sets appearing in at least 50% of the transaction are considered to be frequent. Next on generate association rules. So here, now that we have frequent item set, we have generated association rules which will help us to uncover relationship between them. And then let's try to run it. I think there is one missing num item set. I'll just copy paste this in case of any error, uh, to reduce it. Okay, 1 second. I need to solve that. Hold on a minute. So now we have run our code, that we firstly imported our library, and then generating frequent item set, and then using the number set and generating the associated row. Let's try to run this. So we have got an empty data frame with columns and index. Now we are generating association rule, that rules that help us to uncover relationship between items. So since it is the not the updated version, so it includes num item set. So I'll just copy paste it in this rules also. Once again, this was existing code itself. I think there's some okay. Okay, these are the common mistakes you should avoid. And now this is our final output, that is ascendant, consequence, and all the columns, and it will not call the transform cell automatically in future. And this is how it does. And now we'll talk about the applying the confidence difference criterion creation. So confidence different uh, criterion measures the absolute difference in confidence between a rule and its reverse. This helps how the systematic rule this helps how asymmetric a rule is, and its formula is confidence difference is equals to mod of confidence from A to B minus confidence from B to A. Now computing the computing the confidential difference creation, that is again about the rules, is equals to absolute of rules minus, I think that's a code. So let's just copy the code. 1 second. Okay, so confidence different creation. So we already discussed the formula, and let's try to run this code where the rules are the absolute of confidence and the rules are the. So we have got our output here. Here, confidence difference column shows how much confidence a rule differs from its reverse. A larger value indicates more significant difference. Now applying confidence question creation. So confident question creation calculates the ratio of confidence between a rule and its reverse. It is the ratio that highlights how one direction of a rule dominates over the other. And its formula is confident quotient is equals to confidence from A to B minus confidence from B to A. So this is our code here. Let's try to run this. So here the confidence quotient column indicates the dominance of one direction of the rule over the reverse. The value is greater than 1, that suggests stronger confidence in one direction. Now the visualization of our plot. So we have imported matplotlib and Seaborn, and it makes easier to understand and interpret association rule. And here we have created plots. I think because of some error happening, it is not visible, but I'll surely share an image afterwards. And that's it, how we mine association rule in Python. And we explored how to use appropriate algorithm to find frequent item set, generate and evaluated associate rule, and using advanced matrices like confidence difference and confidence quotient. Visualize the rules made to make insights easier and interpret. If you find this video helpful, do like this video, and thanks for watching.